Welcome to the program. My guest is my great friend, Ed Murphy. Ed is an astronomer at the University of Virginia, and so today we're going to take all the politics and all the Trump and all of that and just set it aside and have a conversation about what's going on in space. Ed, welcome back to the program.
Thank you, Coy.
Very glad you're here. So let's start with the news that broke recently when NASA announced the discovery of what is potentially a number of Earth-like planets all revolving around the same sun. Do I have that right?
That's right, yeah. So it's a nearby star. Its name is TRAPPIST-1, and what NASA announced the discovery of is 7 Earth-sized planets that are orbiting around this star. And all 7 are orbiting very close to the star, and 3 of the 7 are in the perfect zone to possibly have liquid water.
The Goldilocks zone.
The Goldilocks zone, or the habitable zone. And the reason the habitable zone is interesting is that's where liquid water could exist, and we think that liquid water is an essential ingredient for life. So if these planets have water on them, those are the ones that we would go to look at.
It's not too, and the reason it's called the Goldilocks zone, it's not too close, it's not too far away, it orbits its own sun, its own star, just in the right spot where there could be water.
That's exactly right. So if you're too close, you're much too hot, the water either evaporates or boils away. If you're too far, it's all frozen, like Pluto in our solar system, which is largely made of water ice, but is completely frozen. But there's this magic zone where you can have liquid water on the surface called the habitable zone. And these 3 planets, 3 of these 7 planets are right there in the heart of that habitable zone. But it's important to know that we don't yet know whether they have liquid water on the surface or not. We just know that they are Earth-sized, and they're in the right place to do this. But astronomers don't yet have the techniques to determine whether those planets have liquid water or not.
And remind us how they can tell that they're there and how they know where they are in relation to their own sun.
So the technique that we're using, the most promising technique for finding planets right now, the one that has turned up the most planets, is where we look for the dimming of a star as a planet passes in front of the star. It's like a mini eclipse. If you imagine looking at a planetary system edge on so that the planets pass in front of the star, and if you're carefully monitoring the brightness of the star, every time a planet passes in front of it, you'll notice the star gets a little bit dimmer, and in this case it gets dimmer for about 30 minutes to an hour, and then it will recover. Now, there are lots of things that could cause a star to dim a little bit. The dimming, by the way, is much less than 1% because the planets are much smaller than the star. So there are lots of things that could cause that dimming, but the true indication that you have a planet is that the planet orbits around and does it again. And again,
the
and again.
Dimming is at a regular interval.
It's exactly, and that it's that pattern of regular intervals of dimming that lets you know that you're dealing with a planet here and not something else.
How do they know it's in the Goldilocks zone?
So once you know the orbital period, how long it takes to go around, you can use the laws of orbital mechanics to determine how far away it is from its parent star. So the period tells you how far it is from the star. And then from calculations based on how much energy the star is giving off every second, you can determine if that's the right distance to have liquid water.
Now, we've found these kind of planets before in other Goldilocks zones around other stars, right?
That's right. Thanks to a mission called Kepler, which stared at over 100,000 stars, 24 hours a day, 365 days a year, about 150,000 stars, monitoring their brightness every few minutes. It's discovered over 3,000 confirmed planets that we know thanks to the Kepler mission, another 2,500 potential planets, and out of that range, they've got about 10 Earth-sized planets in habitable zones around their parent star.
So this discovery was pretty monumental in that it was 7 around the same star, 7 potentially life-holding with water around one sun.
Around one star. And what's also really interesting about this new system is that it's very close to Earth. It's only 40 light years away from us. And that will make it easier to study these planets in detail. A lot of the Kepler planets are hundreds or in some cases over 1,000 light years away. This one is literally in our backyard.
It's in our neighborhood. It's right there. So, but yet we don't have the technology to go there. My daughter asked me that last night. Well, can we send a probe or can we fly there? And I'm like, no, not really.
No, not. Yeah, with the technology we have right now, a system like TRAPPIST-1 at 40 light years away, we're looking at 700,000 years to get there. And we don't have the technology to travel for 700,000 years through space.
Yeah, that is just amazing. It's really exciting. And this kind of research looking for these planets it continues to go on all the time. I mean, there's graduate students and astronomers and PhDs. When they get up and go to work, this is what they do.
Yes, this is one of the discoveries that I think will go down in history as one of the greatest discoveries of the end of the 20th century. So when we look at the 20th century astronomy, the big discovery was the expansion of the universe. But towards the end of the 20th century, the discovery of planets outside our solar system will go down as just this tremendous discovery. And it's one of the hottest fields in astronomy today.
Really?
Yeah.
Yeah.
So there are tons of faculty working on it, graduate students researching these things. There's a NASA satellite in orbit now, the Kepler mission, which is continuing its mission to look for planets. There's a follow-on mission that is being planned right now to pick up where Kepler has left off. And there are many ground-based telescopes that are searching for planets.
So Ed, what's the general thinking now among astronomers about life beyond our solar system, about the potential for life on these planets that we know are about the size of Earth? They're in the correct distance from their own sun to very likely have water. And if there is water in the right place in relation to their sun, there's very potentially some kind of life on that planet. What do astronomers think?
So some of our thoughts on that have changed and some haven't. The important one that has changed is if you and I were holding this conversation 20 years ago, I would have said, I think planets are common around other stars, but we don't know. And now we know, and we know they're common. We know that, in fact, in our galaxy, it is likely that planets outnumber stars, and our galaxy has a few 100 billion stars. So there could be 1 trillion planets in our galaxy or more. And we also know, based on these surveys, that Earth-sized planets in habitable zones are common. So that's the big thing.
And that's new.
That's new. That's what we've learned in the last 20 years, is that planets are extremely common. Earth-sized planets in habitable zones are likely common as well. And those are observed facts now about the universe. The problem is how many of those Earth-sized planets have liquid water on them. And then the question for the next generation of astronomers are those Earth-sized planets that have liquid water, do they have life? And we don't have the technology to address that yet. So I can't answer that question. So our thinking on that hasn't changed, which is, for scientists, we're going to look for the water because we think water is essential for life. Then someday we're going to have to figure out how to look for life there. There are certain signatures you could imagine. If you had a water planet that had an oxygen atmosphere, like our Earth does, oxygen is a signature of life on the planet. Oxygen is a very reactive gas. It wants to rust everything. Without life constantly replenishing the oxygen in the atmosphere would disappear relatively quickly. So if you could find a planet with an oxygen atmosphere, then you would know that there was life on it. But we don't have the technology to do that right now.
Yeah. What's your own personal thinking of the chances beyond the solar system that there's life? Not necessarily life that evolved from primates like we did on this Earth, but that there's some kind of life that we would recognize as life.
The only thing that I have to go on when you ask that question is how easy was it for life to develop on Earth? That is, the Earth forms, how quickly did life form on the Earth? And the answer is almost right away. So within a few 100 million years of the formation of the Earth, there's early evidence for life on Earth. And life on Earth seemed to form so easily and so quickly after the Earth formed that my personal opinion, but I only have one example, the Earth, but my personal opinion is that if you have a planet where the conditions are right, it seems like it's easy for life to develop, which makes me think then, with all these Earth-like planets that might be out there, that those Earth-like planets would also have life, at least primitive life on them.
Yeah, and if you take the example of Earth to go on, an incredibly rich diversity of life.
But the important thing to know about the Earth's diversity of life is what we think of as that rich diversity of life is really recent in Earth's history. For the vast majority of Earth's history, life on Earth consisted of nothing but single-celled organisms, little tiny algae living in the oceans. And so the vast majority of those Earth-like planets out there, so the Earth formed 4.5 billion years ago, and we don't get really complex life on Earth until about the last 550 million years or so. So for the first 4 billion years of the Earth's history, there was nothing but simple organisms on Earth. That makes me think that most of those planets that have life probably have simple-celled organisms.
Which you wouldn't necessarily see with the naked eye.
Oh, no, not at all.
Even if you were just standing there in their ocean, you'd need a microscope.
You might need a microscope. You might be able to see algae, but those algae, the important thing that they do is they release oxygen. At least that's what they did on Earth. And that oxygen in the atmosphere is a clear signature that you've got life.
Yeah. It's so fascinating. I want to ask you about the new telescope that's going up very, very soon. Fill us in on this because it's going to make huge headlines. It's already started to make it. It's been in the works for a while. What is this thing and what's the potential for this new space telescope?
So many people know that we're retiring the Hubble Space Telescope. Hubble has been in orbit for over 25 years now. It is definitely at the end of its life, and we no longer have the ability to go up and service the Hubble Space Telescope. So it has been decided to retire Hubble, and we now have almost completed the follow-on to the Hubble Space Telescope called the James Webb Space Telescope. And to give you an idea of the difference between the two, Hubble has a mirror inside that's 2.4 meters across. The James Webb Space Telescope mirror is 6.5 meters across. It's going to collect 5 times as much light as Hubble did and show us details that are half the size of what Hubble could show us. And that's good. You know, the smaller the detail you can see.
So it's going to be able to see much, much further into space.
Exactly. It'll be able to see more than twice as far, objects that are twice as far, and objects that are much smaller. You'll be able to see detail at much greater distances.
So what is this? What are you looking for after? And when does Webb go up? 2019 or is that
2018?
2018.
The current scheduled launch date is October of 2018.
Okay. So what are among the first things you're looking for when they fire that thing up?
So I think the two most promising things that Webb are going to study is the first one is we're going to see for the first time clear images of galaxies forming. So the Hubble Space Telescope can see far enough in the universe that we just get to the edge of where galaxies are beginning to pull themselves together. And that process of how galaxies formed is not well understood. So what Webb will allow us to do is look a little bit further than Hubble did, but see a lot more detail back then and show us exactly how galaxies like the Milky Way built up. The second thing it's going to do, related to our first topic, is that it's going to study the atmospheres of these extrasolar planets. When that planet passes in front of its parent star, if it has an atmosphere, the light from the star passes through the atmosphere.
And bends.
And well, it bends, but it also gets some of the light, particular colors of light get absorbed by the molecules and the atoms that are in the atmosphere of that planet. And we can then determine what molecules and atoms are in that planet's atmosphere. We can determine the composition of the atmosphere.
Based on the colors.
Based on the colors that are usually disappear out of the spectrum.
And that's the work you do, right?
I do that kind of spectroscopy.
Right.
And so this will actually tell us what the composition of the atmospheres of these planets are. That kind of work can be done now with the Hubble Space Telescope and with some ground-based telescopes, but it's just barely on the edge of what we can do today. But the James Webb Space Telescope should make that much easier and should make it much more common.
So if I understand you right, we're launching a space telescope next year that's going to be able to tell us for sure if those Earth-like planets in other systems have an atmosphere.
Exactly.
That's mind-boggling.
Yeah, so we already know for a couple extrasolar planets that they do have atmospheres. For some of the giant ones that have passed in front of their parent stars, we've seen that they have hydrogen and helium atmospheres, very much like the gas giant planets in our solar system. So for these Earth-sized planets, though, which are much smaller, it's a lot harder to do. But it will not only tell us that they have an atmosphere, it'll tell us if they have they'll look for water vapor, for example, in the atmosphere. And that water vapor would be an indication of liquid water on the surface. Yeah, water vapor is one that the James Webb Space Telescope should
this new telescope will be able to confirm for us if those planets that we have discovered actually have water in their atmosphere.
It might be able to.
Ed.
It's a very, very tough observation. It would be.
And we're right on the verge of this, of knowing this, of this discovery.
So James Webb will be launched in October of 2018. If everything goes well, it should be up and operational by mid-2019. And then the goal is that it will operate for 10 years.
That's amazing.
It is. And to see the James Webb Space Telescope, it's a fascinating machine. It's certainly going to be the most complex thing that humans have ever launched into space, because the telescope is so big. There's no rocket big enough to launch it. So the telescope actually launches all folded up. And it's like origami. This thing is folded very carefully inside the rocket. It gets launched. It's going to get launched about 1 million miles from Earth. It's going to be farther from the sun than the Earth is, at a point out there called the L2 point. And when it gets out there, it will unfold itself and unfold its mirror, and the secondary mirror will fold up. We've never built anything this big and this complex before.
So it's not going to be like up there with the satellites orbiting the Earth, which aren't very far above the Earth.
No. Yeah, so the James Webb Space Telescope is optimized for looking at a kind of light you and I can't see called infrared light. Heat disturbs infrared light. The telescope itself emits infrared light. The infrared light from the Earth would interfere with the observation. So the telescope,
we got to send it way out
We're
there.
sending it way out there, and the telescope has a giant sun shield on it about the size of a tennis court that will block the light from the sun, and the telescope will remain in the shadow of the sun shield, and that has a couple advantages. It not only blocks the sun's light, but it allows the telescope to get very, very cold. Ultimately, it will be about 50 degrees above absolute zero. Not just the camera inside, but the whole telescope will be that cold, because if it's any hotter than that, the telescope itself emits infrared light, which overwhelms the infrared light coming from the distant object.
That is so exciting.
Yeah.
That is just absolutely so exciting. It's ingenious.
It is.
No, wait. It's science.
Yeah.
And science is awesome.
That's right. And in this case, I think we have to give a lot of credit to the engineers as well. It's science and engineering. This thing is an engineering marvel.
It's amazing. I got to take a really quick break. And when we do, let's talk about the search for water on other planets right here in our solar system. We'll do that when we get back with UVA astronomer Ed Murphy. Stay with me. We'll be right back. Welcome back. We're talking with Ed Murphy, an astronomer at the University of Virginia. Ed, we were talking during the break about one of the challenges of the James Webb telescope, which goes up next year, is that it's not close like Hubble has been, where we can just go up and fix it if we need to.
That's right.
Everybody remembers that we had to, when Hubble went up, the mirror was messed up. We had to go up and fix that.
That's right.
Otherwise it wouldn't work.
And Hubble's only 350 miles above the surface of the Earth, and it was designed to be serviced by human beings. But James Webb will be a little less than 1 million miles away, and it is not designed to be serviced by humans. So we have to get everything right on the James Webb.
We can't go
Space
back
Telescope.
up there and fix it.
No, that's right. Exactly.
Is it how, in terms of distance from the Earth, is it past the asteroid belt? I mean, is it?
No, yeah, so the asteroid
Or it's
belt,
inside that?
it's well inside. So,
Okay.
so the distance from the Earth to the Sun is 93 million miles, and this will be a little less than 1 million miles away from us.
Okay.
So it's not beyond Mars. It's still, it's the best way to put it is about 4 times further than the Moon.
Is it the kind of thing that we wouldn't be able to see it at night because it'll be in the shade blocking any light from the sun?
That's right. And at 4 times further than the Moon, we wouldn't see something as small as even the tennis court. The size of its sun shield will be too small to see at that distance.
Let me ask you about, to change the subject here, I want to ask you about Europa. Remind folks what Europa is, where it is, and why it should be, everybody should be thinking about Europa.
Yeah, so Europa is, I think, in our solar system, the most promising place to look for life. Keep following on to what we said before, it's liquid water seems to be the key. We're searching for liquid water on Mars, or at least where liquid water used to be in the past. But we know that there is a body in the solar system that has a substantial amount of liquid water. In fact, it probably has twice as much liquid water as the Earth does, and that's Jupiter's moon Europa. Jupiter has 4 large moons, Io, Europa, Ganymede, and Callisto. 3 of them are icy moons, and Europa has an icy cap with a liquid water ocean underneath it. And that liquid water ocean, I think, has the best potential for having life beyond Earth.
How big is Europa relative to the Earth?
Europa is a little bit smaller than our moon, and our moon is about 1/4 the size of the Earth, so it's a little bit smaller than 1/4 the size of the Earth.
And how far is Europa?
So Jupiter's about 5 times further from the sun than we are, and so the sunlight out there is going to be much dimmer. And on top of that, the liquid water doesn't exist on the surface, but it exists below an icy cap that's about 25 kilometers, which is about 15 miles thick. So if you wanted to get to
Wow.
that liquid water ocean, you would have to drill down through 15 miles of ice. We don't know how to do that yet. But the exciting news in the last few years is that NASA is finally developing a mission. And the great news is it looks like it's not one but two missions to go visit Europa and study it with the specific goal of determining whether there is life there or not.
Right, and we may not be able to drill down through that 15 miles of ice into Europa's ocean, which covers the whole
Right.
moon, but water shoots up out of that ice, doesn't
Exactly, yes. So there are places on the surface where we believe the ice has cracked. The Hubble Space Telescope has seen observations of material venting out of Europa. And just looking at the surface, you can see that the ice is clearly cracked in many places, and something has welled up in those cracks and frozen on the surface. So the goal is to send an orbiter there. It would launch sometime in 2022, and it would arrive a few years later if NASA can build a giant rocket to send it directly there, maybe 5 years later if we have to use a smaller rocket. And it will spend a number of years passing by Europa multiple times, studying the surface and picking the best place to send a lander. And then about 5 years later, the lander will launch, and then the lander will get there probably sometime around the year 2030 or 2031, land on the selected spot on the surface and look for life in Europa.
Amazing. And how does it do that? If it lands on that icy moon and finds a place where there's cracks,
Right.
where we assume that ocean water has bubbled up and frozen, what's it going to do?
So that's what was just recently done with this spacecraft, was they just defined its science mission, how it's going to do that. What they're going to do is land on the surface, and they're going to dig about 4 inches deep into the ice so that you get ice that's not right on the surface but is about 4 inches down. And then it's going to take 5 samples of that ice and bring them inside the spacecraft. And the first obvious test that they're going to do is they're going to melt the ice and use a microscope to look for cells, to look for microbes. But even if they don't see microbes, there's the possibility that those microbes have been destroyed over time. So a second device is an ultraviolet spectrometer. It uses ultraviolet light, and it's going to look for organic compounds. Another signature of life on Earth is that all life on Earth is carbon-based. It's based on organic chemistry. So they will look for these organic compounds in the water, in the frozen ice, to determine whether there's any organic chemistry going on.
Just amazing. This is just so exciting. And amazing to think that we're finally going to do that. I know you and I have spoken a number of times about we need to get to Europa.
That's right.
How can we get to Europa? And it's finally happening.
It's finally going to happen. And I think by the year 2030, 2031, when that lander gets there, not long after that, we may finally know the answer. If it doesn't discover life, it doesn't mean that there's not life on Europa.
Of course not.
But the chemistry of that water, the chemistry of the ice that they look at, will tell us a lot about the possibilities that there could be life there.
And if there is signs of organic chemistry in that water,
Then
what else? What other proof do you need?
The danger of that.
You don't necessarily have to hold a fish on Europa.
Right. So there's the organic chemistry, though, is quite common in the universe. It turns out the organic chemistry that makes up you and me is the common chemistry of the universe. Here at the University of Virginia, there is a big astrochemistry group, and they study, in many cases, organic compounds that are out in space. So there are specific kinds of organic chemistry they'll look for. But I wouldn't be surprised at all if they found some organic materials there.
Right. Oh my gosh. And then hopefully one day we're going to have a little rover submarine that we can shoot down into the ocean of Europa. And I mean, that day will come.
That day will come. I don't know that we will live to see it.
We may not live to see it.
That technology is so far beyond what we can do now. But that is everyone's dream, would be to land on Europa, get down through the ice, deploy some kind of submarine under there, and see what's underneath that ice.
Speaking of new technology and dreams, let's get an update on SpaceX. Remind us what SpaceX is, and they're doing some amazing things.
That's right. So SpaceX is a private spaceflight firm that was founded by Elon Musk, and he got into the business of building rockets and spacecraft as a private company. They started with some simple launches. Now they're launching cargo up to the International Space Station. But most importantly,
that's a first, right? That just happened.
So they just delivered their latest cargo a few weeks ago, but they've been delivering cargo to the space station for a few years now. So, but Elon Musk wants to make spaceflight inexpensive. And he believes the way to make spaceflight inexpensive is to reuse those rockets. A typical rocket costs between $60 million, and the big rockets can cost a few $100 million to build. And I think what a lot of people don't realize is when we launch a rocket, as those stages fall off, they fall into the ocean, they're destroyed, they're never reused again. Imagine how expensive air travel would be if you got to Europe on the airliner and they destroyed the airliner and they had to build a whole new one to send you back home.
Yeah.
But that's what we do in the spaceflight business because bringing those stages home was so expensive. But SpaceX has now managed to do this, and 6 times they have managed to bring back one of these first stages and land them with the hope that they'll be able to quickly and inexpensively refurbish them and reuse them
So
again.
that's the huge cost of space travel right now, is the rocket, is actually getting somebody off of the Earth and through the atmosphere.
That's right, yep.
And they figured a way to take you up and then bring the rocket back down.
At least the first stage of the rocket. Eventually they'll work on bringing that second stage of the rocket back. So that first stage is estimated to cost between $20 and $30 million. So by bringing that back, they can reduce the cost of their launches by $20 to $30 million.
And what's the goal? Is space tourism?
Well, so Elon Musk's long-term goal is a human colony on Mars, and he's been quite clear about this, that he believes that if humans don't have a foothold someplace other than Earth, we're in a very fragile situation. If anything ever happens to our home planet, then there's no place we don't have the technology to go anywhere else right now. So he wants us to have a foothold on Mars. So his long-term personal goals are to develop the capabilities to go to Mars. But he's doing that piecemeal right now. So he's using this contract with NASA to develop his rocket. They're developing a spacecraft that can carry humans that late next year will have its first flight with humans going up to the International Space Station. And he's one of 2 private companies that are developing spacecraft that can carry humans. Sorry, that's mid next year. And then late next year, he has 2 tourists who've already put a down payment on a flight around the moon.
And Americans may not know that space tourism has already been around for a while.
That's right. Yes, 7 individuals have paid to get launched on Russian rockets up to the International Space Station. And they typically spent about 7 to 12 days on the International Space Station before coming home. And so space tourism has happened a number of times before. It's never happened in the U.S., but though many of the individuals that flew were U.S. citizens just flying on Russian rockets.
Including a UVA graduate.
That's right.
Yeah, who knew? Ed, thank you for being here.
Thanks,
Let's
Coy.
talk again soon. It's always great to talk with you. Ed Murphy is an astronomer at the University of Virginia. You can find the complete archive of this program online at mediaandcitizenship.org. Have a terrific week, and y'all be good to each other.